So, June 2nd. It probably just seems like another totally ordinary day on the calendar, right? But it's actually quite possibly one of the greatest hidden holidays in math history. Today in this explainer, I'm going to show you exactly why this single date acts as an invisible thread, seamlessly connecting some of the most brilliant minds across centuries. It's honestly an incredible story of how seemingly unrelated discoveries ended up building the exact reality that we live in right now. Because on this exact day, across completely different centuries and continents, these absolute geniuses were laying the foundation for the very technology you're using right this second to watch this. They didn't know each other, obviously, and they were trying to solve vastly different puzzles, but their collective work fundamentally changed the modern world. So let's dive into the first puzzle piece. Okay, think about the super realistic 3D graphics in your favorite video game, or how digital artists can render perfectly smooth, lifelike curves on a screen that is, well, completely flat. It looks entirely natural to us now. We totally take it for granted. But how does a computer actually know how to draw a curved surface without making it look like a jagged, blocky mess of pixels? It's an incredibly difficult problem for a machine to solve. Well, the answer actually traces all the way back to June 2nd, 1895, with the birth of a brilliantly curious Hungarian mathematician named Tibor Radó. He was the man who basically cracked the code of digital surfaces decades before modern computers even existed. Long before anyone was even dreaming about virtual reality or video games, Radó was just deeply, obsessively fascinated by the hidden geometry of the natural world. So, Radó managed to solve this massive mathematical headache called the Plateau problem. Simply put, he figured out how to calculate what we call minimal surfaces. Picture a soap bubble just floating in the air. It naturally forms this perfect, smooth shape, and it does that using the absolute least amount of surface area possible. By turning the actual physics of a soap bubble into pure math, Radó inadvertently wrote the exact geometry that our modern computers use today to render seamless 3D graphics. Which leads us to this incredible realization. Whenever you're exploring a massive virtual world, flying a digital spaceship, or just, rotating a 3D model on your screen, remember, every 3D video game you play is secretly made of math. You're essentially playing inside the complex calculations of a 19th century soap bubble enthusiast. How cool is that? All right, let's keep moving down the timeline. We are still on June 2nd, but we're going to jump from 1895 to 1929. We're moving to a completely different country, and we're diving into an entirely new, massive problem to solve. We're shifting from the smooth surfaces of 3D graphics to the invisible, somewhat chaotic pathways of global communication. Think about what happens to a pair of wired headphones when you shove them in your pocket. They instantly tangle into an impossible knot, right? Every single time. Now scale that up. Imagine the entire internet, millions of emails, streaming videos, and secure messages bouncing around the globe all at the exact same time. How on earth does the network route all that massive traffic without tying itself into a catastrophic, chaotic digital knot? Well, this digital mystery is solved by the pioneering work of an Austrian mathematician who passed away on, you guessed it, June 2nd, 1929. His name was Otto Schreier. In his tragically short life, Schreier laid down mathematical principles that were entirely abstract at the time, but would eventually become the ultimate rulebook for the digital age. Schreier was an absolute master of this mind-bending field called combinatorial group theory. In layman's terms, he solved the mathematical logic of knots and braids. He figured out the underlying rules of how lines cross, weave, and untangle. Today, network engineers use his incredibly abstract theories as the absolute foundation for internet routing algorithms. His math finds the perfect untangled pathways to keep your digital data flowing smoothly and instantly. It's wild to think about. What if the pattern of a tangled knot is also hiding inside your Wi-Fi network? The next time you're streaming a 4K movie without any buffering, consider this fascinating truth. The exact same math that unties a physical braid is busy untangling your digital packets before they even reach your router. And the story doesn't stop there. Let's make our next jump along the timeline to 1946. Still that magical date, June 2nd, but we are entering entirely new scientific territory. We're moving away from the invisible software of internet routing, and we're going to focus on the actual physical hardware that sits right in the palm of your hand. Take a second and really look at the device you're watching this on right now. It's displaying millions of vibrant, perfectly calibrated colors, all safely housed inside this beautifully sleek, tough casing of glass and metal. That physical magic isn't an accident, and it certainly didn't happen overnight. It requires a really deep understanding of how the physical world operates at a microscopic level. The science that makes that brilliant display and that tough exterior possible points directly back to a Scottish physicist named William Penney, who passed away on June 2, 1946. Penney was a relentless investigator of the physical world. He was totally obsessed with understanding how both human biology and physical elements interacted with light and force. Penney explored the deep mathematical rules behind human color vision, basically figuring out how our eyes actually perceive light and how our brains make spectrums. At the exact same time, he experimented heavily with the physical atomic properties of metals. Today, those foundational discoveries are combined to help engineers craft both the vibrant, color-perfect pixels on your screen and the incredibly durable metal alloys that hold it all together in your pocket. So remember this the next time you're endlessly scrolling through your social feeds or looking at high-res photos. The brilliant colors in your pocket actually started as a 20th century physics experiment. The stunning visuals we completely take for granted are the direct result of decades of intense mathematical experimentation with light and metal. Now, we actually have to rewind the clock just a little bit for our final stop. We are stepping back 4 years on the timeline to 1942, but still landing right on our absolute favorite calendar date. It's time to talk about something that feels almost like magic when we use it in our daily lives. We've all experienced this, right? You're driving down the highway and suddenly your GPS app just automatically reroutes you, saving you from this massive traffic jam miles ahead. But how does your phone predict the future of a highway before you even get there? How does it instantly know exactly how long the delay will be? The final puzzle piece of our June 2nd highlight reel is the brilliant Scottish mathematician Andrew Forsyth, who died on June 2nd, 1942. Now, Forsyth wasn't working with smartphones or satellites, obviously, but he was busy mastering the exact language those technologies would eventually need to speak in order to function. Forsyth wrote the definitive British books of his time on differential equations. Now I know, that sounds like an absolute nightmare from high school math, but really, it's just the ultimate mathematical tool for predicting how things change over time. If you know how fast a car is moving and exactly how traffic is accumulating, you can literally predict the future. We use Forsyth's foundational math today in our GPS apps to constantly recalculate speed, time, and ever-changing road conditions right on the fly. It gives us our final big realization of the day. Every single time an app predicts the future, it is just using the math of change. It's practically a modern superpower. Whether it's forecasting the weather, predicting the stock market, or just getting you to the grocery store 5 minutes faster, it all comes down to differential equations. So that's one incredibly special date on the calendar. And 4 completely fascinating, world-altering stories. From 3D surfaces to digital knots, from color physics to predicting the future of traffic. But what is it that really connected them all, aside from a random date on a calendar? The crucial point is this. Every single person we met today, separated by decades and borders, looked at a wildly chaotic universe and asked the exact same question. How do we find the pattern? Because they dare to look for the invisible rules hiding inside the chaos. Our world today is equipped with instant GPS routing, untangled internet pathways, breathtaking 3D graphics, and vibrant digital displays. Which leaves us with one final inspiring thought to close out this explainer. If a simple soap bubble or a tangled knot can change the entire course of modern technology, where is the math hiding in your life today? Keep your eyes open, because the underlying magic of our universe is literally all around you.